Welcome to the Explainer. You've seen them everywhere, right? These absolutely incredible, mind-blowing images created by AI. Well, today we're going to pop the hood and take a look at the secret engine that's making it all happen.
So you've probably done this, right? You type a few words into an AI art generator and bam, out comes this masterpiece. And you're left wondering, how in the world did it do that? Well, the secret is this one specific part, this core component that for the longest time was actually holding the whole thing back. But, and this is the cool part, it has just been completely reinvented.
All right, so here's what we're going to cover. First, we'll look at that secret engine. Then we'll talk about the old way of doing things and why it was so limited. We'll get into the new rule-breaking idea, see the incredible results, and wrap up with why this is a huge deal for the future of AI. Okay, Section 1, AI Art's Secret Engine. We're moving beyond just pixels to actual ideas. Now, here's the first thing you gotta wrap your head around. These AI image generators, they don't really see pixels like you and I do. No, they operate in this special kind of abstract space where images aren't a bunch of dots, but, well, they're concepts, ideas. So how do they do that? Well, the magic tool is called an autoencoder. And it's actually pretty simple when you break it down. Just think of it like a super skilled artist's assistant. It has two parts. First, there's the encoder. Its job is to look at a super detailed painting and just boil it down to a few key notes, like a summary. Then you've got the decoder, which takes those simple notes and, like magic, rebuilds the entire painting from them. It's a two-step process: compress, then reconstruct. All right, let's talk about the old way of doing things. For a long, long time, the standard autoencoder that everyone used, it's called a VAE, it really only cared about one thing, and one thing only: compression. Just squeeze that image down, make it as tiny as possible. That was the whole game. In that super compressed code, it lives in a place that researchers call the latent space. You can think of it as the AI's imagination. It's that world of ideas where it does all its work. But here's the problem with the old way. Because it was so obsessed with squeezing, that latent space wasn't full of rich, detailed blueprints. It was more like a collection of tiny, fuzzy, kind of blurry postcards. You know, you get the general idea, but all the beautiful details, gone. And yet, this obsession with just shrinking everything down, it caused some major headaches. I mean, for starters, the design was old and super inefficient. It took like 6 times more computing power to run. But honestly, the bigger problem, the real issue, was that it lost the meaning of the image. It was so focused on compression that it forgot what the image was about. It could see, brown fur, green grass, white sphere, but it couldn't connect those dots to understand a dog is chasing a ball. The whole semantic structure was just lost. Okay, so this is where things get really interesting. You've got this whole field kind of stuck in a rut. And then a team of researchers comes along and decides to question this one big fundamental belief that everyone just took for granted. So for the longest time, the rule in AI research was basically this: you have to pick one. You can either have an autoencoder that's really, really good at understanding the meaning of an image, the semantics, what it's all about, or you can have one that's amazing at perfectly recreating all the pixels. But you couldn't have both. It was an either-or situation. But what if that was just wrong? What if everyone had it backwards? That's the simple question this new research asked. What if you didn't have to choose? What if an AI could get the what and the how perfectly? And that question led to this, the RA breakthrough. The answer is a brand new model called a Representation Autoencoder, or RAE for short. And let me tell you, it doesn't just tweak the old approach. It flips it completely on its head. So let's look at the side-by-side. The big difference is the goal. The old way, the VAE, its goal was just aggressive compression. Shrink it down. The new way, the RAE, its goal is meaningful representation. And here's the genius move. Instead of building an encoder from scratch and trying to teach it about art, the RAE just borrows one. It takes a powerful, pre-trained AI that's already an expert at understanding images and plugs it right in. It's literally like firing your intern who's good at making photocopies and hiring a world-renowned art historian to write your notes instead. The quality of the representation just skyrockets. Okay, so it's a brilliant idea, right? But the real question is, does it actually work? I mean, what do the numbers say? Well, let's just say the proof is in the data, and the results are pretty staggering. First up, quality. This chart shows a standard score for image generation quality, and here, lower is better. The old models were hovering up around 3 or higher. The new RAE-based models, they absolutely crush it, down at 1.13. That's a new state-of-the-art score. In plain English, that means the images it creates are way more realistic and way more accurate.
Then there's the speed, and this is just wild. We're not talking 10 or 20% faster, we're talking 47 times faster. These new models learn so much more efficiently. They get to the same or even better performance with just a tiny fraction of the computer power. That is a game changer.
Now, this table right here, this explains everything. It shows us why it works so well. Look at the first row, reconstruction quality. The RAE is a bit better, sure, but look at that second row, representation quality. This is how well the AI understands the image. The old model, a measly 8% accuracy. The new RAE, 84.5%. That's not just better, it's a completely different league. It's over 10 times better at actually getting what the image is about.
So let's zoom out. What does all of this mean for the future? Because this isn't just about making AI art generators a little bit better. No, this is a whole new foundation. It's a fundamental shift in how we even think about building this stuff. The big takeaway is this shift right here. We've gone from thinking of this component as just a compression mechanism, a simple tool for making files smaller, to seeing it as a representation foundation. The autoencoder just got a massive promotion. It's not the file clerk anymore. It's the chief architect, laying the groundwork for AIs that can actually understand things on a deep, meaningful level. So it leaves us with this huge question. This breakthrough isn't just about prettier pictures. It's about building a new generation of AI that's way more capable and way more efficient. It's about developing tools that can truly understand the visual world in ways we're probably only just starting to imagine. What comes next? That's going to be exciting to see.